I know her birthday's in March.
Does it count it as
So how did the meeting go? She did? I was like, I told her because I was like on Wednesday or Tuesday.
I was like, what was really confused.
Why would I bring a bag back there?
Morning. Good morning.
I was like, Mom, you know this was you guys.
Okay, guys, so today we're going to move on to section 4.5. If you'll get out a sheet of paper for notes. We'll go ahead and get started. Remember, tomorrow you'll have a lab day, and then on Friday you'll have a quiz over section 4.4 homework, which was Monday's assignment. So I'm going to switch over to my document camera real quick, and then we'll get started. Ms. Press, can you guys see my document camera? Yay! 2 for 2. Alright, so guys, this is section 4.5 in your notes. We actually have one more section of chapter 4, and that will finish up all of the material actually for the semester. And we'll spend the remainder of the time reviewing for your final exam. Just keep in mind that we will have a chapter test a week from Friday, so that'll be over chapter 4. So I hope to do 4.5 today, finish 4.6 up on Monday, and then spend a couple of days reviewing before we take the chapter 4 test. In section 4.5, we're talking about properties of logarithms. So just a little recap. Remember in section 4.1 we talked about composition between two functions. In 4.2 we talked about inverse functions. And then in 4.3 is when we started talking about the exponentials. So we talked about the exponential family in 4.3. Then 4.4, we learned the basics of logarithms. Today we're going to continue talking about logs and just learn some more of the properties that are involved when you're dealing with logarithms. And then in 4.6, what we'll do is bring exponentials and logs together, and we'll solve those exponential and log equations in that last section of chapter 4. So the first thing that I need for you to have in your notes as far as properties of logs are concerned is that if you have something like log base A of a to the x power, log base A of a to the x power. This property says that if you have a logarithm with base A, and you're taking that logarithm of an exponential base A, since logarithms and exponentials are inverses of each other, they cancel each other out, leaving you with the exponent. So in this case, the answer would just be x. Over here to the side, I'm going to give you a few examples of that property. So my first example would be something like log base 5, excuse me, log base 5 of 5 to the 4th power. I have a base 5 on my logarithm. I have a base 5 on my exponential. Because of this inverse property, the two cancel each other out, leaving you with the exponent. So the answer is just 4. If I give you something like log base 7 of 7 to the 3x power, this property says that is equivalent to what? Just 3x. Good. If I give you log base 10 of 10 to the 2x plus 3, this property says that is equivalent to what? 2x plus 3. Great. And then a special case of that is when you have log base e, which is natural log. If you take natural log of e to any power, let's say natural log of e to the 5th power, this same property tells us that natural log and e are inverses of each other. They cancel each other out, leaving us with the exponent, which happens to be 5. Because remember, natural log is just log base e. So if you take log base e of e to some power, the answer is just that power. So that's your first property of logarithms. If you have the same base on the logarithm as you do on the exponential, they're going to cancel each other out and leave you with the exponent. The second property is very closely related. It's still an inverse property, but this time you have an exponential raised to a logarithm. So if you have an exponential base a raised to a logarithm base a, the exponential and the log cancel each other out and leave you with the expression that you're taking the logarithm of. So in this case, just x. And some examples over here to the side of this property would be if you have something like 4 to the log base 4 of 3. The answer is just 3. Because again, you have the same base on the exponential as you do on the logarithm. They're inverses of each other, so they cancel each other out. Another example of that would be if you have something like 7 to the log base 7 of 4x minus 5, where 4x minus 5 is inside parentheses. Then this property says that's equivalent to what? 4x minus 5.
If that expression was not in parentheses, would it change what happens?
Yes, if the expression 4x minus 5 is not in parentheses, then we wouldn't be able to apply this property directly. We would have to do some tweaking first. However, let's say I gave you one like this, 8 to the log base 8 of 5x. And I didn't have parentheses around the 5x. I can still apply that property to this example. This would tell me that it's just 5x. Because the parentheses would be understood to be around the 5x. Now, in this case here, if I didn't have parentheses, they would be understood to be around the 4x only. And then the minus 5 would be on the outside, and that would create a problem for us in using this property. But if you just have a single term after the logarithm, you can certainly go ahead and apply the property.
Okay.
It's because there were multiple terms in the second example. That's why I said we'd have to tweak it a little bit before we'd be able to use it. And then my last example is if you have e to the natural log of 7. This property says that's equal to 7 because, again, natural log is just log base e. So e to the log base e cancel. They're inverses of each other, leaving you with just plain old 7 in that case. Any questions so far about the two inverse properties? All right, well, the next 3 examples are dealing with expanding and condensing logarithmic expressions. So I'll go ahead and tell you that in this section you're going to be doing a lot of just practicing the properties. I'll give you an expression and you'll be practicing using the properties. We are not actually applying them to anything yet. For some of you this may be the first time that you've seen the properties, so we're going to crawl before we walk. Next time in 4.6 we'll actually use these properties to help us solve some problems. But for right now, in this section, we're really just practicing using the properties. We're not applying them yet. So the third property that I want you to have in your notes is a property which states if you have log base a of x times y, you can expand that to be log base a of x plus log base a of y. The fourth property is if you have division, like log base a of x divided by y, you can expand that to be log base a of x minus log base a of y. Ms. Crest, I didn't hear that question.
They were just making sure that that was a plus sign in between on the first one.
Oh, okay, yes. Yeah, so on number 3, and I'm sorry, I should have said this before, but on 3, I'm going to give you properties 3, 4, and 5, and then we'll do several examples using those properties. So 3, 4, and 5, I'm going to just give you the property first, and then we'll do several examples involving those 3 properties. And then property number 5 is going to be if you have log base a of x to some power, which I'm calling n. You can pull that n down to the front and multiply it times log base a of x. Those are the expanding properties of logarithms. Now, let's think about this for a second before we do some examples. So what I'm saying to you right now is that with logarithms, multiplication implies addition, division implies subtraction, and raising to a power implies multiplication. So think about where else in math class, somewhere in your career, that you've heard properties that are similar to that or connected to that. Multiplication tells you to add, division tells you to subtract, and raising to a power tells you to multiply. Yes, very good. Exponent rules. Does everybody remember your exponent rules? When you're multiplying with the same base, you're supposed to add the exponents together. And when you're dividing with the same base, you subtract the exponents. And then if you're raising a power to another power, the rule is to multiply them together. Well, that's not a coincidence because remember, exponentials and logarithms are inverses of each other. So it's not a coincidence that they would share some of the same properties. So if you know your exponent rules, it makes it easier, I think, to remember your log properties if you just think about your exponent rules that you've been using for several years now. Probably since Algebra 1 at least. All right, let's try some examples. And so my first example, I want you to expand. Now, I can't remember right off the top of my head in this particular textbook, but some textbooks, when they're wanting you to expand, they say something like, use the properties of logarithms to rewrite the expression. So it might not actually say expand in your textbook, but if it says to use the properties of logarithms to rewrite the expression, that's what it's wanting you to do. It's wanting you to take a single logarithm and expand it into multiple logarithms. So my first example is going to be log base 3 of x over 9. And so we're going to use our properties of logarithms to expand that expression. Now notice I'm taking the logarithm of a quotient. I have two terms being divided. So we just said that division implies what operation? Subtraction. So I can rewrite this expression as log base 3 of x minus log base 3 of 9. So you take log of the numerator and subtract the log of the denominator using property number 4 that we wrote in our notes. Division implies subtraction. I can actually take this one step further because we all know what log base 3 of 9 is. 2, good, yes. So this is going to be log base 3 of x minus 2, and that's where I'm actually going to stop. I will say that if this had been like log base 3 of 7, where the answer were a decimal answer, I would prefer that you just leave it as log base 3 of 7. You're only going to simplify it if it turns out to be a nice pretty number like an integer or a fraction or a terminating decimal. Let's try another one. This time we're going to do log base 7 of xy to the 5th power. Log base 7 of xy to the 5th power. So hopefully you notice that I have two things going on here inside my expression. I have a product, two things being multiplied together, and I also have an exponent on the y to the 5th. So what I'm going to do first is I'm going to expand the product, and we said that multiplication implies addition. So I'm going to rewrite this as log base 7 of x plus log base 7 of y to the 5th. And then in my second step, I'm going to bring down my log base 7 of x. And I'm going to use property number 5 to pull that exponent on the y down in front of the logarithm base 7 of y. So it's going to be plus 5 log base 7 of y. So we're expanding it until there are no other properties that we can apply. You keep going until you no longer have a product, a quotient, an exponent, or your logarithms cannot be simplified any further. Again, right now we're just practicing using the logs because you might be thinking, so what? I mean, why are we doing this? We're just practicing using the properties right now. They will help us in the next section when we actually apply it to something.
If the exponent was on the outside of parentheses, would you just put your equation in parentheses and then like put the exponent in like the 5 in front of it?
That is an excellent question, which leads me to example 3. I'm glad you asked that. You are a step ahead of me. Number 3, the question here was what if the exponent were on the outside of the parentheses? And it definitely does change the way we think about the problem, doesn't it?
Yeah.
So, in example 3, I'm going to do the same problem pretty much, but I'm going to put the parenthesis on the, or the exponent on the outside of the parenthesis. So log base 7 of xy to the 5th power. Now you actually have a couple of options here on how you would proceed. One way to think of it is what you could do is you could go ahead and use property number 5 and pull the 5 down first. That's one option. If you do it that way, you have 5 times log base 7 of xy, and then you expand it from multiplication to addition. But you have to be really, really careful if you choose to do it that way, because if you do, you need to make sure you put parentheses around the log base 7 of xy after you expand it. So log base 7 of x plus log base 7 of y. Because the 5 actually is going to be distributed to both the log base 7 of x and the log base 7 of y, since both of those terms were being raised to the 5th power. So you would write your final answer as 5 log base 7 of x plus 5 log base 7 of y. That's one way to think about it. I'm actually going to show you an alternate way to think of the same problem. What we could do on an example like number 3 is we could actually rewrite it as log base 7 x to the 5th y to the 5th first. Just raise everything on the inside of the parentheses to the 5th power first before we expand it. Then from there, expand it to log base 7 of x to the 5th plus log base 7 of y to the 5th, and then apply property number 5. So it's hard for me to tell you, or I actually can't tell you just in general, you need to do property 5 first and then do property 3 and then do property 4, because depending on the problem you might use one property before the other. So you have to really pay attention to what the original question starts as, because just the placement of one little parenthesis can change the way you approach the problem. To finish this one out, we would pull the 5 down in front of both the log base 7 of x, and let's go ahead and pull it down in front of the log base 7 of y. So notice I get the same answer either way.
Do you have to show like the middle step, like if this were to be on our quiz or something? Like,
that's a great question too. You do not have to show every single step that I'm showing up here. You certainly want to show some of your steps so that I can see your thinking. You're talking about on the quiz, right? Or on a quiz, if you had it on a quiz. I would like to see your thinking, but I do understand that some of you, especially on some of the smaller ones, can go straight from the question to the answer, and I understand that. Just be really, really careful if you do, because again, sometimes we get careless and you might only pull the 5 down in front of one of the logarithms in a case like number 3. And so skipping steps, just if you do, make sure you're very, very careful. And then when these are some smaller problems, they will get more complex, and as they get more complex, the need for more steps will be greater, I think. Any other questions before we move on? All right, let's try a couple of natural log problems. So in number 4, I want you to take the natural log of E divided by xy. So notice I have both multiplication and division. In this case, I'm going to suggest that you expand the division first so that you can rewrite it as ln of E minus ln of xy. Now, we do have a property for ln of E. That's one of our inverse properties from property number 1. ln and E are inverses of each other, so they cancel each other out, leaving you with the exponent. And so what would the exponent be on base E? Yeah, just 1. So ln of E is just 1. And then I'm going to subtract off the natural log of xy, but I'm going to expand it. And because I have a subtraction here, I'm going to make sure to use parentheses and do natural log of x plus natural log of y. Now, if you don't use parentheses, you're probably going to miss this question if you don't think to distribute the negative. Well, you will miss it if you don't think to distribute the negative, but you might forget is what I was getting at. The actual answer would, on a multiple choice test, would probably look more like this. 1 minus ln of x minus ln of y. So since both the ln of x and ln of y were in the denominator of the fraction, you'll see that they're actually both negative in my final answer. So 1 minus ln of x minus ln of y. If you have multiple terms on the bottom of the fraction, make sure you distribute that negative to all your terms. Let's do one more expanding, and then we're going to go in the opposite direction. I'll give you a large expression, and then we'll work our way back to a single logarithm. But let's do one more expanding first. Number 5, I want you to do natural log of x squared y over e cubed. And actually, I want you guys to try this one. I'm going to walk around and kind of see if you can do it on your own. So write it on your paper. And then Ms. Press, will you mind to walk around and check the papers there at Southern?
Yeah.
Okay. Let's let them try this one on their own. So you're just expanding, and make sure that you simplify.
Is that E cubed?
Yeah, that denominator should say e cubed. So it's ln of x squared y over e cubed. Remember that your numerator comes first when you're expanding the division. So you want to take the natural log of the numerator, the top of the fraction, and then subtract off the natural log of the denominator. So that should be your first step.
No.
And if you want me to check it, just raise your hand. I'll come to your desk. I'm just glancing around right now. Oh wait, except for you don't need an Ellen. Is the Ellen and the E cancel? Yeah. But other than that, it looks great. And they're both on top. Yeah, that looks good. The two down in front and this one and two down.
Yeah, it would. Maybe it's just like
Maybe it's in
all of the business all of it.
This is good. This your first step is perfect. Now just go one more step.
over exaggerated.
Did I make that? Oh my god.
Like, and this is like.
I know, it like bounced off the rim.
On the corner of my neck. Is it not actually?
I know, right? I don't like rainbow flowers.
We're all good here. Okay, almost finished here. I'll be right there.
I thought you'd get something other than the answer.
From where?
Yeah. Just like that.
Yeah. You said you wanted it.
Yeah, I only eat it like go out of my way.
This is the teacher.
Is there anybody that I didn't get a check? I think I made it around to everybody. Okay, so just to make sure everybody understands real quick, the first thing that I would do on this one is change it to ln of x squared y minus ln of e cubed. Some of you skipped this step, and that's okay. You went straight into the next step, which was ln of x squared plus ln of y minus ln of e cubed. And then for your final answer here, you're going to pull the 2 down in front of the ln of x. You're going to bring down your ln of y. And then, of course, natural log and e cancel each other out and just leave you with the exponent, which is plain old 3. And so this is what your final answer should look like. 2 ln of x plus ln of y minus 3. Any questions before we go in the opposite direction? Any questions about that?
So it's only on the bottom when you distribute?
Oh, yes, great question. So you only have to worry about distributing the negative if you have more than one term on the bottom. So the numerator is going to stay positive, x squared y, but the denominator is going to be subtraction. So only if you have multiple terms on the bottom do you have to worry about distributing that negative through. Any other questions about expanding? Yes?
Would it be wrong to put parentheses around the 2 ln x and ln y?
Not at all. If you want to put parentheses here, like that, perfect. Yeah, you can leave it like that if you want to. You can have parentheses around the 2 ln of x plus ln of y, and that would be correct as well. Anything else you guys can think of before we move on? Okay, so now we're going to go in the opposite direction, and we're going to condense. So I'm going to give you a large expression, and I want you to condense this expression into a single logarithm. Write as a single logarithm is usually what most textbooks ask you to do. Write as a single logarithm. So what was this, number 6? Okay, so number 6 is going to be 2 log base 3 of u minus log base 3 of v. So when you think about condensing, now you should be thinking multiplication implies an exponent. Subtraction implies division. Addition implies multiplication. So we're thinking about these properties in reverse. So on this example, the first thing I'm going to do is I'm going to move the 2 up to the exponent on the u only, because the only thing being multiplied to is the log base 3 of u. So it's going to look like log base 3 of u squared minus log base 3 of v. And then from there, we know that subtraction implies division. So I'm going to condense these 2 logarithms down to 1 log. So it's going to be log base 3 of u squared divided by v. And that's going to be my answer. Log base 3 of u squared over v. So anytime you go from subtraction to division or from addition to multiplication, you're condensing from 2 logs down to 1. So notice that your logarithm should be on the outside of the fraction. You should only have 1 logarithm in your answer. And it should not be inside the fraction. It should be out in front of it. Let's try another one. Let's do log base 2 of 1 over x plus log base 2